In this next example, we want to analyze the equation 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. And in this problem, we're going to have to use the idea of completing the square. So I want to make sure I get all my x terms together, all my y terms together, and I'm going to move my constant to the other side. So I subtracted my 4 from both sides of my equation, and I collected all my x terms together and my y terms together. And because I'm going to have to complete the square, I went ahead and left some blanks here so that I could do that. Keep in mind when you do that, you have to do something to both sides of the equal sign, so that's the reason I have these other two blanks on the right-hand side as well. As we start to take a look at our x terms, notice that these two terms both have a 4 in common, so I'm going to go ahead and take the 4 out. Now that I've done that, I can start taking a look at my middle term so that I can complete the square. Keep in mind I want to take that term and divide it by 2, and then I want to square it. So 2 divided by 2 is going to give me a 1, and when I square that, I'm going to get a positive 1 to put on this blank. Now remember, you can't just add that term to the left-hand side without doing it to the right-hand side, so I need to make sure I fill in this blank over here as well, but not with a 1. Keep in mind you factored that 4 out, so 4 times 1 is going to give me a positive 4, so I'm going to fill in this blank with a positive 4. And now I can work with my y terms. So I'm going to take the 4, divide it by 2, and square it. 4 divided by 2 is going to give me 2, and 2 squared is going to give me 4. So I'm going to fill in these last two blanks with a positive 4. Now keep in mind that the whole point of doing this completing the square step is so that you created a trinomial that was a perfect square. So I should be able to factor this trinomial, and both of the sets of parentheses are going to be the same. So let's go ahead and work with our x terms first here. When we factor this trinomial, it's going to factor into x minus 1 times x minus 1, and we don't want to lose the 4 that we had out in front. So I could also write this as 4 times the quantity x minus 1 squared. Let's go ahead and do the same thing now with our y terms. We want to go ahead and factor this trinomial. That's going to factor into y plus 2 times y plus 2, and I can rewrite that as y plus 2, the quantity squared. And now I can go work with the right-hand side of my equal sign, and combining all my terms here, it's going to give me a positive 4. Now we're not quite done. We want to write this in standard form so we can start getting some information off our equation. Keep in mind when you are working with an ellipse, you want this number on this far right-hand side to be a 1. So in this case, I'm going to take each of my terms here, and I'm going to divide by 4. When I do that, I'm going to get x minus 1, the quantity squared. You don't necessarily have to write this over a 1, but I'm going to just so we have a denominator to work with. My second fraction here is going to be y plus 2, the quantity squared, over 4. And on the other side of my equal sign, I have a 1. So from here, let's go ahead and get the center of our ellipse. Keep in mind, the inside piece of your formula here should always read x minus a number or y minus a number. So our h and k values here are going to give us the point 1, negative 2 as the center of our ellipse. As we're looking at this equation, let's notice a couple other things. Looking at our denominators here, the 4 is the larger number. That's going to be our a squared value. And you recognize that it's under the y terms. That's going to indicate that the y-axis or the vertical axis is going to be our major axis in this example. Our a value is 2 in this case, And that's going to be the distance from the center out to one of our vertices. Keep in mind our center is not the origin in this example, so let's make sure when we go to plot those vertices that you are counting from the point 1, -2, which would be the center. Our b value is going to be a 1, and that's going to be the distance from the center out to one of the points on the minor axis. And to get our c value, we're going to be subtracting these two numbers. So 4 minus 1, that's going to give us a 3. That's our c squared value. So when we take the square root of it, square root of 3 is going to be our distance from the center out to one of our foci. So let's go ahead and start plotting some of these points that we have. Our center is at the point 1, -2. And remember that the vertical axis is our major axis in this case, which means our ellipse is going to be taller versus wider. So let's take a look at our a value first. Our a value was 2, and that's the distance from the center out to one of our vertices. So in this case, we're going to be counting up 2 units and down 2 units from our center to get our vertices. Sometimes it's easier to go ahead and plot your points first and then get your coordinates. So I counted up 2 units and down 2 units. Keep in mind in the graph that I'm working with, 1 unit is really 2 blocks. So my V1 value here is the point 1, 0, and my vertex number 2 is the point 1, -4. I decided to work with my B value next. My B value in this case was a 1. So from my center, I'm going to be counting left and right 1 unit along my minor axis to get my points that would lie along my ellipse. So for my point number 1, I'm going to have the point 0, -2. And for P2, I have the point 2, -2. Now let me go ahead and plot my foci. Keep in mind when you're plotting your foci, those are going to lie along the same axis as your center and your vertices. So it needs to be along this vertical axis right here. So from my center, I'm going to be coming up or down radical 3 units. So one way I could write these points, they're both going to have x coordinates of 1. So my y coordinate would be a -2 plus radical 3. And this other y coordinate would be -2 minus radical 3. I'm going to go ahead and take these out to decimals just to the nearest tenth so we have an idea of where they would fall once we plot them. So here they are as some decimals, a y value of -0.3 and a y value of -3.7. So they sit really close to those vertices. Now let's go ahead and draw our ellipse. Remember that you are connecting your vertices through the points. The foci should remain on the inside part of your ellipse. And there's your final graph. You can definitely see that this ellipse is taller versus wider, which is what should happen when your major axis is along one of the vertical axes.